Hi folks, this is a short video segment which is a follow-up to the one that I did today, and it deals with sensors in Catia FEA. Now, the purpose of this video is to show you that just because you can pick something and it will give you a number on the screen, a value on the screen, doesn't necessarily mean that it makes sense, or it doesn't mean what you think or were expecting to see. Here is the problem that I want to do it. I want to do it in that context. It's a very simple beam, 13 inches long. Left end of it is clamped, and the right end of it is subjected to downward load of 100 pounds. However, it's assumed that the material in the middle three section is a lot stiffer than the material on the two sides. Okay. If that is the case, there is no reason to model the middle portion with solid elements. If it's very stiff, we can assume, for example, it's a rigid connection, and and avoid modeling the internal portion. Okay. The fact that I'm talking about rigid connection, you could have done it with a smooth connection. The difference is that rigid connection assumes that the square 1 by 1 cross section on the left and the square 1 by 1 cross section on the right, they don't change shape. If you do it with a smooth connection, then of course those faces are subject to change, but still the middle portion is a lot stiffer than the rest of the structure. Okay, so I will be doing this thing assuming that the two pieces on the right and left are made out of steel, but that's totally irrelevant. So let's go ahead and do this problem, model it. Start with the part file. Okay, and on the vertical plane, I will sketch a square 1 by 1. So this is 1, and this is 1. Exit, and padded by 5 inches. That'll give you the piece on the left side. Now I want to do the same thing on the right side. There are different ways of doing it. For example, you can go, this is not necessarily the best way, but I'm going to create a plane, offset from that, 3 inches. And on that plane, I will sketch a square just like that. So maybe I project that square. There's a project on that face. Exit, and then pad it by 5 inches. Do it any way you want. Just get the 5 inch, and then this gap in the middle. Okay, now let's apply some material on this. We agreed to do it with steel. That's totally irrelevant. On that part, we say okay. And why don't we save everything? File, save management, save as, my desktop, desktop, new folder. I'll make it July 4, 2020. Rigid connection. Okay. Now we're going to go to generative structure analysis, static analysis, but I'm going to make the element a little bit smaller, although we're not doing any accuracy study here, and the size of this element again is not going to have an impact on the thing that I want to show you, but I'll make it smaller. Psychologically may look better. Oh, that's too small now. 0.3. Then I use linear element, but that's totally irrelevant. So the mesh is going to look like that, which is fine. We don't care. Deactivate the mesh and do the rest of the problem. Okay, so first of all, I want to clamp the side, clamp this face, okay, and apply 100 pounds on the face on this right side. This face, downward. Okay, and then we want to create a connection between this face and the one on the left. So where is the connection? General analysis connection right there. You can see that. You click on it. For the first component, you select that face. For the second component, you pick the other face. There, that face. There is a connection. And we declare this thing as rigid connection. Remember, when it comes to connection properties, you have these two toolbars on the left side. One of them is the face-face connection property, which is not what I want. The other one is distant connection property, and that's what I want. Rigid, there's rigid here. You click on it, and you select that particular connection that you made, and you say, okay, there we are. We're going to run it in a second, but let me hide these planes. Stuff that I don't need, I'm going to hide. Just so that the screen is not cluttered with all that stuff. This plane I don't want. And representative element I don't want. Oops, that one I don't want. Very good. Okay, so save everything. File, save management. In that same folder, we save it. Okay. And we're going to run it. Nothing unexpected is going to happen. This beam is going to bend. You can see there's the deformation, stresses. Okay. Biggest stress at the clamp, and the stresses gradually, because that's where the biggest moment is, by the way. And this middle portion is rigid, so presumably there's no display, there's no deformation in it, stresses in it. Now, this patchiness, you know what it is for. It's because the mesh is not good for the purpose that we have in mind. You can make it smaller, or you can go to parabolic, but that is not the purpose of this particular presentation. So let me deactivate this plot. My interest is saying something about sensors, okay? All right, so you put the cursor here, right click, you say, for example, let's create a reaction sensor. So create resultant sensors, and down here, reaction sensor. And it says, okay, where is the support that you want to find the reaction at? There's only one support here, that's this. Okay, and then you say update. Notice what it gives you as the force. For the force, it gives you at this support 100 pounds up, and there we are in the Z direction, because we applied 100 pounds down on the right side. So, and of course, this is 0. There is no other force acting here. Okay. Now, when you go to the moment, it gives you 100 times the distance of 13 inches about the x-axis. You're going to get 1300 pound-inch. And of course, the moment about the other two axes is almost 0. Pretty much 0 for all practical purposes. Good. So we got it. There is the reaction sensor. Now, what I also could have done was this. Sensor, again, reaction sensor. And I may have accidentally or on purpose, not knowing what's going to happen, selected instead of that support that I did earlier, this connection. And I say update. You might say, okay, so what is this? I didn't take a support. I took a connection. Am I supposed to get for example, the free body diagram, forces acting on this face or on that face? Should I be eliminating, should I be ignoring the pieces that I modeled? And this is going to be the forces acting at the end of the reaction, the connection. And the answer is just watch your number. These are exactly the same thing that we got before. Let me close that. Let me close this. Say okay, and look at the thing that was generated. And these are almost the same numbers that we got before. So we picked it. We picked a connection. But what we got has nothing to do with the connection. It has to do with the reaction force at that support. So here to convince you, if you go back to these slides, this is what we did. Clamped end, 13 inches in length, 100 pounds. If we separate these, into individual pieces and draw the free body diagram for it, for example, if you look at this piece on the left, well, we already know this is 100 up, 1300 in the counterclockwise direction, and obviously this has to be in equilibrium. This piece has to be in equilibrium, so there has to be 100 pounds down, and instead of 1300, 800 clockwise, because that moment arm is 5 times 100, 500. Basically 1300 is 500 plus 800. Now if these are going to go appear on the connection on this side, these are exactly the same thing, okay? And for this to be in equilibrium, there has to be 100 pounds down, and again 500 clockwise, because this 500, this 100 times 3 is 300 plus 500 is going to balance that. And finally, these are transferred to the right hand side, and this is so what we got in the tree as these numbers have nothing to do with the virtual part, not the virtual part, I'm sorry, the rigid connection. We thought the thing that we were picking had something to do with the maybe that rigid connection, but the numbers that we generated is still the reaction force at the wall. So just because we were able to pick something and generate the numbers, it doesn't mean it has anything to do with the thing that we picked. It still gives you the reaction force at the wall. I wish the Catia documentation would remind us that yes, we're picking this, but it doesn't mean it has anything to do with the connection that we pick. Just be aware of the fact that just because you can get numbers or generate color doesn't mean that you're getting what you're expecting. That's it.